All right, let's get into it. When we think about a car's engine, we usually picture all the mechanical parts, right? The pistons, the explosions, all that metal moving around. But there's something else in there, a kind of ghost in the machine, a digital brain that makes it all work together in perfect harmony. I mean, really think about that for a second. Whether you're starting it on a freezing morning or hitting the gas on the freeway, that engine has to adapt instantly. So how does it know precisely how much fuel to use, or the perfect moment for a spark? Well, it's not magic. It's actually a super, super fast conversation happening under the hood. And honestly, that's the best way to wrap your head around this. We're going to use a simple analogy here, the human body. Because your engine's control system, it has a central brain making all the decisions, it has senses to feel what's going on, and it has muscles to carry out the commands. What's so wild is just how far we've come. Old cars were all about clever physics, things like springs and weights that would move as the engine sped up. It was all purely reactive. But today, it's a whole different ballgame. It's a proactive digital system where all the logic is just lines of code in a computer. So, let's start at the top of the food chain with the most important part of this whole system, the brain itself. This is mission control for the entire operation. It's called the Engine Control Unit, or you'll hear it called the ECU. You can just think of it as a small, rugged, and incredibly fast computer. Its only job, its entire reason for existing, is to run the engine perfectly. It's not checking email, it's making millions of calculations every single second. And its to-do list is massive. We're talking about managing the precise amount of fuel, deciding the exact microsecond to fire a spark plug, keeping the engine running smoothly when you're stopped at a light. It even has to talk with the transmission and the brakes. It is, without a doubt, the boss. But, a brain is pretty useless if it's just sitting in a dark room. It needs info. It needs to know what's going on in the world. And that's where the engine's senses come into play. This huge network of sensors feeding the ECU data all the time. These sensors are literally the engine's eyes and ears. They take things from the real world, like temperature or pressure or how fast something is spinning, and they translate it into the only language the ECU brain understands, an electrical signal. Now, just like with our own bodies, not all senses are created equal. An engine can kind of work around a faulty temperature sensor, but there is one sense it absolutely cannot live without, and that is the crankshaft position sensor, or CKP. The whole system is built around what this one sensor has to say. This little guy provides the two most critical pieces of information, period. First, how fast is the engine spinning? That's your RPM. And second, exactly where is the crankshaft in its rotation? Without those two facts, the ECU is completely lost. This sensor is the heartbeat of the entire system. And this is the absolute bottom line. If that CKP sensor fails, the brain goes completely blind. It has no idea what the engine is doing, so it can't time the fuel, it can't time the spark, the engine will turn over, but it will never start. It's that important. All right, so let's look at another critical sense, but this one is on the other end of the process. If the CKP is listening to the heartbeat, the oxygen sensor is basically analyzing the engine's breath, the exhaust coming out the tailpipe. So this sensor sits in the exhaust, and it sniffs for oxygen. Why? Because the amount of leftover oxygen tells the ECU if its last combustion event was successful. If there's lots of oxygen, the fuel mixture was too lean. If there's hardly any, it was too rich. This feedback loop lets the ECU make tiny adjustments on the fly, always trying to hit that perfect 14.7 to 1 air-to-fuel ratio for the best efficiency and the cleanest burn. Okay, so the brain has gotten the data from its senses. It's made a decision, now what? Well, it's got to do something about it. It needs to flex its muscles. And in the engine world, those are called actuators. An actuator is basically the opposite of a sensor. It takes an electrical signal from the brain and turns it into a real physical movement. These are the doers of the system. They are the hands and feet that carry out the brain's orders. And the perfect example of an actuator is the fuel injector. It's a tiny, super fast electronic valve. Now, the ECU doesn't really change the fuel pressure. What it controls is time. It tells that injector to open for a very specific number of milliseconds, spraying a perfectly measured mist of fuel. Another key muscle is the ignition coil. And how this thing works is just plain cool. The ECU sends the car's normal 12-volt current into the coil, which slowly builds up a magnetic field. Then, at the perfect instant, the ECU cuts the power.
That magnetic field collapses instantly, and that rapid collapse creates a huge surge of electricity in a second coil wrapped around the first one.
And when I say huge, I mean it. We're talking about turning 12 volts into 40,000 volts or even more. That's enough power to jump across the spark plug gap and create a powerful spark to light the fuel. And the ECU does this amazing magic trick for every single cylinder, hundreds of times every second. It's incredible. So we've met the brain, the senses, and the muscles. Now let's put it all together and see how they work in this constant, high-speed dance.
This is the basic logic of how the whole system runs. It's an endless loop. First, you have input. The sensors report what's happening. Second is process. The ECU takes all that data, looks it up on these pre-programmed tables called maps, and decides what to do. And finally, output. It sends the commands to the actuators, the muscles, to make it happen. And the most important thing to remember here is the speed. This entire loop, input, process, output, is happening hundreds and hundreds of times every single second. It's this non-stop, dynamic adjustment that makes a modern engine feel so smooth and powerful.
Okay, so we've gone through a lot of technical stuff, but why does any of this really matter to you when you're just driving to work? What's the real-world payoff for all this amazing complexity?
It all boils down to three main things. First, performance. All this precise control means you can squeeze every last bit of power out of every drop of gasoline. Second, efficiency. The engine is never wasting fuel because it's constantly adjusting. And third, emissions control. That same precision is what allows modern cars to run so incredibly clean. This system is already a marvel of engineering, but believe me, it's only getting smarter. As these car brains start using real AI and machine learning to not just react, but to actually predict what's needed, well, what new levels of power and efficiency are they going to unlock? That's the really exciting question for the next generation of cars.